Hi there, welcome to edupediaworld.com. You're watching the videos on area of parallelograms and triangles. So in this video we'll discuss introduction to area of parallelograms, so how area of parallelograms and triangles are related. So you have to watch this video very carefully. So this is the first video on area of parallelograms and triangles. Then we'll discuss figures between, like how we can prove that area of parallelogram or triangle are equal or how they are related according to whether they lie on same base or between same parallel lines. Then we'll discuss how congruency helps us to recognize whether the two figures have equal areas and they are between the same base and same parallel lines. So let's discuss the first topic, which is introduction to area of parallelograms. Now, the introduction says that two figures are said to be congruent if they have same shape and size. So let's see the first figure. Now, if you see this figure properly, they are exactly of same size. They are of same size and shape. So how? Let's say if we can fit this figure onto this, let's say, or we can say that if we can superimpose, A on B, then the figure A will exactly fit on figure B. Then we can say that these two figures are congruent. Now if these two figures are congruent, then they must have equal areas. So this is how the congruency helps us to recognize whether the two shapes have equal area or not. Now let's see these two figures. Now in these two figures we can clearly see that if we see the area of ABCD triangle, it will be 4 into 9, which is 36 centimeter square. And if we seek the area of EFGH, so which is 6 into 6, so which is 36 centimeter square, then you can see that both the areas are equal. So if both the areas are equal, so if we follow the converse of, like say converse of congruency, then if the two areas are equal, then these two figures should be congruent. So this is however not always a true, or this is not always a true. Why? Because if we try to superimpose this figure onto this, then it's not possible. And we can say also that these two figures have different shapes. So in the end we can say that if two figures are said to be congruent, that is if they have the same shape and size, then there we can say they must have equal areas. However, if two figures have same area, then we cannot say that they are congruent. So for congruency, they should have a same shape and same size, means they should exactly superimpose on each other. So this is the first and the last criteria for congruency, which helps us to understand the area of parallelograms and triangles. Now let's discuss the example related to this. Now the example is, let's say if we have a figure like this. Now, and figure T, this whole figure is named as T and it's divided into two figures, P and Q. Now these are made of two planar regular regions formed by P and Q. Now you can see that area of figure T is equals to area of figure P plus area of figure Q. Means if we take this whole complete figure, then we can say that this whole complete figure T is sum of P and Q. Now if we need to write the area, let's say, what's a short form to write the area? Let's say if we need to write the area of figure T, so we can write area of T, and for area of figure of P we can write area of P plus, for this we can write area of Q. Now so we can say that from the figure T we can say that if the figure with the following two properties, we can draw conclusion for the two properties, that if two figures, let's say A and B, are congruent, then area of A should be equals to area of B. However, if we have a case like this figure, in which we cannot superimpose the figure P on Q, then we can say that area of T equals to area of P plus area of Q. So this is how the congruency can help us to understand as to whether the two areas are equal, or we can write the two areas as a sum of the larger area. So let's discuss the next topic, which is figures. Now it says that figures on the same base and between same parallel lines. Now if you see the figures on this, we can clearly see that if you, in this figure, A, B, C, D and D, C, F, E, they have a same base DC, So why they have a same base DC? Because these two lines exactly superimposed on each other and they are of exact length. Means in these both the figures, DC is a common side, and from the base DC exactly the two figures are drawn. However, these two figures are not between the same parallel lines, but they are between the same base. So same base means that the two figures should have the same length and the common base. Now similarly, in this figure, the same base, common base is SR, and in this figure the base is BC, and in this figure also DC. However, when you look at this figure, one figure is quadrilateral, ABCD is a quadrilateral, but another figure is DCP is a triangle. However, both the figures are drawn from the same base DC and they are of same length, so we can say that these two figures have a same base and same length. Now if you look at these figures now, however, let's say in this first figure, AB, CD and DC, FE, they have a same base DC. Again, the same reason, they have a same base and same length. Now if you see properly, they have a same parallel lines. You can see it properly. If this is the figure A, B, C, D, and this is another figure, so they are lying between the same parallel lines. You can see properly. So now for this figure, we can say that these two figures A, B, C, D and D, C, F, E, they lie between the same parallel lines and the same base. Similarly, for this figure also we can see SR is a common base and they are between the same parallel lines. You can see properly. If you see this figure and this figure, they are between the same base and same parallel line. Similarly, for this figure also, these two triangles, they have a same base and they are between the same parallel lines. And for this figure also, they are between the same base. The base is DC and they are between the same parallel lines. So this is how we need to use the congruency if the figure lies between the same base and the same parallel lines. So let's discuss the question related to this part. Now in this question, it says that which of the following figures lie on the same base and between same parallel lines. In such case, write the common base. We need to write the common base and two parallel lines. We need to write the two parallel lines. Now if you see this figure properly, the first figure, we have a common base DC, we have a base DC, and the two parallel lines, we can see that if this is the figure ABCD and this is the figure DPC, they are between the same parallel lines AB and DC. So the parallel lines are AB and DC. Similarly, for the figure 2, we can say that they have same base SR. However, they are not between the same parallel lines. See, this figure lies between PQ and SR. However, this figure lies between MN and SR. So this figure doesn't have a same parallel lines. Now, if you look at this figure now, they have a same base QR. They have same base QR and they are between the same parallel lines. We can see properly PS and QR. So they have same parallel lines PS and QR. Now, if you look at this figure now, it's very interesting figure. They have a same parallel lines. They have same parallel lines. Let's say, so these are the two parallel lines. They're lying between the two parallel lines AD and BC. However, they don't have a same base. In this first figure, they have a base BC. However, in this figure, in triangle RQP, they have a base PQ. So they don't lie in the same base. Now, if you see this figure properly now, they have a same base AD, same base AD, and they are between the same parallel lines AD and BQ. So the parallel lines are AD and BQ. Now, if you see this figure properly, the last one, they lie between the same parallel lines SR and PQ. They are same parallel lines SR and PQ. However, the base is not same. The first figure PQSR have a base SR. However, the figure ABCD have the base DC. Now, why the base is not same? Although the base is lying on the same parallel line, but in the first figure and the second figure, they have a different base. Why they have a different base? Because they have a different length of the base. So that's why it's very important to check if the base lie on the same part, but the length should also be same. So this is the very important criteria to check for the base. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.